Assalamualaikum and hi. So we are from group 2. So we are going to present on our lab project, which is smart parking system using Rfid technology. So our group consists of me, which is Ahmad Safian, Shasabilla Binti Azizi, and Siti and Iffah with Ruslan. So I will explain on content or on the project introduction first. So our problem that we want to solve is to minimize the traffic congestion that happens in the parking park, which is a common thing that we've seen every day. And we also want to improve the security level or security feature that not many parking park or parking system park have. So by this, we want to create a systematic and an effective parking system that uses RFID technology, where it will reduce the traffic congestion at any parking park, simultaneously improve the level of security at a parking lot. So it will, so this parking system will only allow an authorized user to enter the parking space. So moreover, in this parking system, we will provide a real-time information on the status of availability of parking slots, and we want to optimize the parking space utilization. So our smart parking system will offer a more convenient and sustainable alternative to traditional parking methods. So we move on to the objective and scope of our project, which is our first objective. We want to implement a smart parking system, which will involve many components such as IR sensor, which we want to detect the presence of vehicle, and also we want to provide a real-time information on the status of availability of parking slot, which we will use an LCD I2C. So finally, we want to develop a high security parking system. So we will equip a RFID technology that will only allow authorized user to park their vehicle to a certain parking spot. So for this RFID technology, the concept is if we have the right RFID card or tag, if we just tag it on the sensor, it will immediately open the servo motor will open the entrance, so we can enter the parking spot and also park our vehicle. So I think we will move on to the simulation of this project.
This is the schematic of the smart parking system in Proteus. We have 4 IR sensors for parking slot, 1 IR sensor at the exit gate, 2 servo motor, entry gate and exit gate, a LCD, a virtual terminal as a substitute to RFID, 4 green LED and 4 red LED, and another buzzer to indicate unauthorized tag. When we run the simulation, the IR sensors will update the LEDs. The green LEDs indicate the availability of parking spaces. When the parking is occupied, the red LED will be turned on. And the LCD will display the parking spaces. A indicate for available, and when it is not available, it will turn to O, which is occupied. P1, P2, P3, and P4 indicate each parking slot. When we turn on to IR1 and IR2, the red LED will turn to red and it updates the LCD, which is P1 and P2 is O, which is occupied, and there is P3 and P4 left. For the RFID function, when we key in the authorized tag for this system, we set to 1234 as an authorized tag and else will be unauthorized. When we enter the tag ID of 1234, the LCD then will display authorized and it will open the entry gate. Now the entry gate is open and the LCD will update back the state of IR sensor. If we insert other than the authorized key, for example, the LCD will and the LCD will display unauthorized, it will ring the buzzer, and the gate is not open. Lastly, for the exit gate, the IR5 is installed at the exit gate to detect a vehicle and it's turned on. And it will open the exit gate. It's also wait for 5 seconds before it closes back.
For the block diagram, we have one RFID and four infrared sensor or called as IR sensor. As the input and through Arduino Uno, we have four green light LED, four red light LED, one LCD 16 times 2 and buzzer as the output of the system. For the system design, we have come up with a two programming flowchart, which is when entering the parking slot and exit the parking slot. Based on the figure 4 shows, the system starts with an LCD displaying the number of available parking spaces. If there are available parking slots, then it will scan the RFID. The RFID then will leave the gate after it settles one vehicle. The LCD will display again the requirement amount of available parking. But if there are no parking space available, then the scanning RFID process will not happen and the barrier gate does not lift up. While for the programming flowchart when exit the parking space, figure shows that on the exit path, the system starts with the sensor that functions to sense the car at the barrier gate. If it happens to send one vehicle, then the barrier gate will automatically lift. Then the system will end with an LCD displaying the increment amount of available parking. There are four parking slots in this project. Figure 1 shows the IR sensor that are located to each of the parking slots and connected with the red light LED and green light LED. When the parking space is available, then the IR sensor scan low, the green light LED switches on. If the parking slots are full, the IR sensors can hide and the red light LED switch on. But if happen that only one parking space is available, then only one of the green light LED will switch on. The same happen when only one parking space is full. Only one of the red light LED will switch on. After the LED shows the signals, the availability of the parking slot will display on the LCD as the output. This is the coding for RFID for authorized user. When RFID reader detects an authorized card, the LCD will display the output as authorized. Then the gate will open. After a delay of the 3 seconds, the gate closes. Figure 3 shows if RFID reader detects an authorized card, the LCD display an authorized user. Then it will delay for 2 seconds. while Figure 4 shows the activation of buzzer when unauthorized detected and deactivated after 3 seconds. Figure 5 and Figure 6 show the coding for the exit gate when the movement of the vehicle detected by RF sensor triggers the servo motor and lifts the gate. Figure 7 shows a code in the project where it involves all of the components used in this project. The IR sensors are connected to analog pins of Arduino. The red LED, green LED, servo motors, and a buzzer are connected to the digital pins of the Arduino. Also, it's important to define the library included such a liquid crystal, the servo motor, and also the RFID so that the user can easily share and also manipulate data in the sketches. Above is the void setup functions that needs to be declared so that the program will run once at the beginning of the programs. In the setup, all of the input component is declared as an input and output components will be declared as an output. Also, in addition, the servo motor is declared as the variable in the programs, which is to open the gate in 90 degrees and close the gate in 0 degrees.
So this is the full prototype of our smart parking system. So we use component of RFD module. As you can see, so motor, exit and entrance, and there are LED red and green to indicate that if the parking is available or not. So we also include an 4 IR sensor which will be put in 4 parking spaces, and this IR sensor will detect uh, uh, any obstacle or car that will park, and instantly will light red if a car already parked. So in this situation for the LCD, we can see that parking one, which is this one, is empty, so it will indicate A, which is available. So what if we put a car like this? So we can see that it changed to occupied, and I think we will move on to other condition of we enter, exit, and enter parking space. So for this prototype, I will demonstrate you 3 conditions. So for the first condition is car entering the parking lot. So let's see this video. So for this process, we have to scan our RFID card to the RFID module scanner. So when you scan, the LCD I2C will display authorized and the servo motor will lift up. So as soon as you step into the parking lot, the IR sensor will detect and red LED will light up. So we move on to the next condition. So the second condition is car cannot enter the parking space due to unauthorized. So based on this video, even if you tag the RFID to the scanner, it will display unauthorized, and you have to leave the parking space by choosing the alternative path. So we move on to the last condition. So for the last condition is we'll demonstrate you on how the process of car leaving the parking space. So based on this video, the IR sensor will light green as soon as the car leaves the parking space, and when it reaches to the servo to the IR sensor, the servo motor will light up, and you can leave the parking space.
At the end of the day, from this project, we are able to create and demonstrate a smart parking system where it can detect an authorized card and unauthorized card user that ensuring security at a parking system using IR sensors. Also, with the helps of LEDs and LCD in this project, makes the system more reliable where it updates the availability of parking spaces. A recommendation that we would like to be added in this system for future scope is we would like to add an IoT application and Android application where it use a mobile app to book a parking and also made payment in it where it can save time and cost efficient at the same time. That's all from us. Thank you.